called this morning's session Global Heating, but Britain Freezing, possibly. It's going to be in two parts, as Tony suggested to begin with, looking about climate in particular, but the second part, I might have a little bit of good news in terms of renewable energy. So it will be towards the end. I guess some folk here might have seen the film The Day After Tomorrow? Not at all? Few? Okay, it's worth having a look at. It is a disaster movie. It's fiction, but it's based on the possibility that something called the Atlantic Conveyor, or the AMOC, as I'm going to be calling it, sometimes referred to as the Gulf Stream, what might happen if that were to collapse. And that's really the feature of this morning. What would happen if the AMOC collapses? The AMOC is the Atlantic Meridional Overturning Circulation, as I'm sure you all know. But more about that in a minute or two. The pink ribbon here, I think this reaches, yes, the pink ribbon here is the warm water current that circulates from the tropics through the Gulf of Mexico, across the Atlantic, up to the northeast Atlantic, near us, near Iceland, near Norway, and it carries warm water at the surface of the Atlantic, and it is massive, absolutely massive. It's between 50 kilometers and 100 kilometers wide. It travels at 6.4 kilometers an hour, which is about the speed that I run at. And the other figure is it carries 15 million cubic meters of water every, what? 15 million cubic meters of water every, well, it's every second. It's huge. So what we're going to think about is the possibility that the film Day After Tomorrow might have some basis in reality. It might not. Let's have a look. So we're going to be looking at these questions based on the research that I've done. Now, a little bit of a sort of health warning. The research that I have done is desk research. I've not spent a lot of time in the North Atlantic with a bucket, but I have spent a lot of time looking at journal articles and newspaper reports and things like that. I'm not a scientist. I do actually have a master's degree in science, but it's not in a discipline that's much use to what we're talking about today, except perhaps just, looking at academic materials and so on. So what we're going to be looking at is, if it collapses, will it matter? Has it happened before? How likely is it that it will happen again? What might be the effects on UK weather? It'll have effects on other things, but we're going to focus on the UK weather in particular. The key question really is, when could it happen? A spoiler alert here, nobody really knows, but there's some interesting, very recent research about that. And then let's have a chat about it. Let's have some discussions about, what you think about this, whether it's something that we as a group should do something about. So will it matter to begin with? That's the first question. And the simple answer is yes, massively. These are some of the things that would happen if it were to collapse, if the circulation, let's call it the Atlantic Conveyor. It's like a huge conveyor conveying warm water, then it sinks, and the cold water then runs back down towards the tropics. And these are some of the things that research has shown. An abrupt slowdown could trigger disruptions across the globe. Sudden rise in regional sea levels, we were talking about that a few minutes ago, Penny, weren't we? Changes in the position of major rainfall and arid climate zones. very worryingly, potentially changes to the Amazon rainforest. Now, I've not done much studying about this, but there are some fears around that it could change the Amazon rainforest into savanna, and then we would lose the carbon sink that is so important to global warming. So it's one of these trigger things. The closing of the AMOC would be a trigger for climate change, as would be the Amazon rainforest. So a trigger could trigger another trigger in that sense. There's likely, arguably, to be more extreme and intense winter weather in Europe. A little bit more about that. This is from a Met Office fact sheet, a similar sort of line: cooling of northern hemisphere, sea level rise in the Atlantic, particularly on the east coast of the US. So US cities could be very vulnerable to a sea level rise and flooding. An overall decrease in precipitation over Europe, particularly during the summer, but more precipitation during the winter, and even more winter storms across northern Europe. Has it happened before? Well, the answer is yes. The researchers that are first mentioned here, Lapointe and Bradley from the University of Massachusetts, have studied the frost fairs of 17th and 18th centuries. In particular, we've all seen images of fires and stalls on the frozen River Thames. And they have identified that the reason for that mini ice age, as they call it, was actually a change on AMOC. Incidentally, do stop me if anybody wants to ask any questions or anything. I'm not a scientist, I may not be able to answer, but I'll give it a go. But do interrupt. I mean, don't let me just waffle on for too long without...
How long ago could this have been, the last?
What these characters discovered was that in the 14th and 13th centuries, there was warmer water heading up the Atlantic conveyor, the Gulf Stream, warmer than it had been previously. And the warm water is less susceptible to sinking. And that then caused a change in the pattern of the Atlantic conveyor. And that, they believe, was the cause of the severe winters that we had 1600s, 1700s. The final one was in 1814, which is this picture. I wasn't around in 1814, believe it or not, but you know, that's what I'm told anyway. How likely is it that it'll happen again? And it all depends, of course, on a number of things. And two things in particular: how much the Earth heats up. Because that affects, I called it the Gulf Stream here for want of a better phrase. That's what we tend to refer to it as, but it isn't technically the Gulf Stream, Atlantic conveyor, or AMOC. I'm going to use the phrase AMOC. So if the water heats up, it's less likely to sink. So the conveyor part, the dropping part, the sinking part to the lower parts of the ocean are less likely to happen. So the Earth heating is a major factor. The other extremely important factor is the Greenland ice cap. Because what happens with fresh water coming into the North Atlantic from the melting ice reduces the salinity of the sea. Salt water is heavier than fresh water, and if there's too much fresh water, it reduces the likelihood of the water sinking, and therefore the conveyor part, the sinking part, ceases. So the warmer the water and less salty the water, the less it sinks. It's as simple as that. So, back to the question about global heating. The Guardian, 10 days or so ago, had this heading. You may have seen it. I suspect there are a few Guardian readers here. Scientists despair amid forecast of at least 2.5 degrees Celsius temperature rise. You remember that the Paris Agreement was to attempt to keep global temperatures rise to 1.5 degrees Celsius by the end of the century, 1.5 degrees above pre-industrial levels. Well, the survey of 380 IPC climate scientists, that's the Intergovernmental Panel on Climate Change. So these scientists were the people who had penned the research articles that have got the name IPCC attached to them. So they are the key people in global heating terms. So they were asked, what do you think will happen in terms of a rise in temperature around the world? 6% of them only thought that we'd hold it at 1.5 degrees Celsius. 6% of them. 77% think that it would be 2.5 or more. And that's getting really serious. 42% think it could be 3% or more. Obviously, the 42 are part of the 77. If you think it's going to be more than 3%, you also 3 degrees, you also believe it's going to be more than 2.5. So that, you know, if you're looking at the maths, it's a bit odd. We all know about all the disastrous effects of global warming above 1.5 degrees. We know what they're already like. We're at 1.2 degrees at the moment. We know what it'd be like at 1.5, at 2.5, or at 3. We know how drastic that would be. But we're not focusing on that today. We're focusing specifically on what would happen if the AMOC collapsed and its effect on the UK weather. We can have other sessions again about global heating generally. But if scientists are worried about air temperatures, they're even more worried about the sea temperatures. This shows how the sea temperatures have changed over the years, so that the red areas are the areas that have risen most in terms of their temperature. And the brown areas are the most. It'd be difficult to spot it on this large map, but if I point the pointer to Greenland, and just off Greenland, there are nasty brown squares, which shows that the water around there has increased in temperature significantly more than the water around the rest of the world.
What period of time?
This is over a long period of time. Let me just try and check what it says in the small print. I'm just trying to remember how long it is, but this is over quite a long period of time. I'll check that out, Sonal. I wondered whether it might say on the bottom there. And what's significant, of course, about that is that the warm waters around there are affecting the ice melting in Greenland very significantly. So that what has really shocked scientists of late is the speed at which the ice on Greenland is melting. It's not dissimilar in the Antarctic, but that's a whole different scenario as well. If you actually look around here, around the bottom, there's a lot of brown squares along the bottom here as well. So for some odd reason, the temperatures in at the poles seem to be going up significantly faster than anywhere else around the oceans. So what might the effects be on UK weather? So a question for you: what does London have in common with Warsaw in Poland, Kyiv in Ukraine, and Winnipeg in Great Lakes in Canada? I know there's a couple of geographers amongst you. They are. They're on the same latitude. Yeah, 51.5 degrees north, roughly. And we know which of those four are the warmest in winter. Which has the mildest winters of those four cities? well, we're living in it. Yeah, we have lovely mild winters that we enjoy here in London, don't we? In fact, believe it or not, these are the average January temperatures for the cities in question. We're plus 5.5, Warsaw minus 1.8, Kyiv, a chilly minus 3.5, and Winnipeg, Edinburgh, incidentally, is on the same latitude as Moscow. And I've been to Moscow in February, and I can tell you, it's snowy and it's very, 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 very cold. So, research shows that the temperature in the UK would drop by an average of 3.4 degrees. I think that's primarily in winter, but I'm not absolutely sure about that. That was something I meant to sort of check out. So winter storms blowing across the Atlantic, they would no longer be able to pick up all the warm moisture that the AMOC would have, that does now bring towards us. So that the winter storms would be significantly colder, bring harsher, wintry conditions, particularly across northern parts of Britain. Snow would lie for months at a time and accumulate to levels that the country is just totally unequipped to deal with. I sound enthusiastic about this, don't I? But it is a little bit scary. And wetter conditions over Northern Europe. I've made a few sort of academic references here, and I've got a list of bibliography at the end that have informed this talk, if people want to sort of go back to the original journal articles and records and so on. A recent OECD report goes even further. It suggests that temperatures in the UK could drop by between 3 and 8 degrees, and that sort of takes us into the sort of realms of Kyiv, really, that sort of winter comparable. And that takes into account that the country has already increased by 2.5 degrees Celsius, so it's even more than the 8 potentially there. Greater levels of snowfall again, reduced rainfall in the summer, leading to a widespread loss of arable land is an implication there. So the impacts on wildlife, habitats, and our way of life would be no less severe than that. This is the big unknown, of course, when it could happen. I don't think there's a lot of debate about if it will happen. I think the scientific community is saying it is inevitable that it will at some point. They're saying that the AMOC is at its weakest for 1,000 years, so that implies it's even weaker than it was during the frost fair's time. What was reassuring was this 2019 report by the Intergovernmental Panel on Climate Change, and they concluded that a full collapse of the AMOC is unlikely this century. And I think everybody took a sort of big sigh of relief that at least we don't have to worry about it. But of course, there's always other academics and other research that comes up with a different conclusion. And that's the same, I guess, with global warming generally and all the things that we talk about. It's not clear cut. There are different views about it. But the one I was particularly interested in was this new study from the University of Copenhagen. And they have used temperature data, ocean temperature data from the last 150 years, and they have concluded, this takes a bit of taking in, with 95% certainty that the AMOC will collapse between 2025 and 2095. So it could be from next year, they're saying, and the collapse most likely to happen in 2057. Now, there are people that have challenged this, inevitably. It's caused some consternation, inevitably. But it has been calculated. It is a serious piece of work. Oh, this is the bibliography. You know, if anybody's interested, you can have a copy of this as to where I've got all this data from. The good news. Okay, everyone cheer up a little bit. Separate tests in California and at Oxford University have proven something very exciting and very significant. You might have already discovered this, I don't know. It's possible to create a process, they find, that ends up with more energy being created than has been put in. Scientists have been working on this for 50 years, and it's only now that they have proven in practice that it can work. They're saying, and a very big health warning on this, that this is only at a minute level that they've proven this. I think about enough energy to boil a kettle or something like that. So it's for it to be scaled up, to be at an industrial level, to affect us all, we're decades away from that. So we are not going to be benefiting from it, but maybe our grandchildren might. And perhaps that could reverse the whole global warming business. Because basically, it would amount to limitless, free, virtually, but green energy for the first time. So that is, oh, hey, I mean, it could be. So I've got, it's all about something called fusion ignition. It's the same physics process as the fusion in a hydrogen bomb, but it's not nuclear energy. It's harnessing the energy that's created within the sun. I'm not going to try and explain it to you, but we have got a little video which we'll show some of. So we'll perhaps have a few minutes of the video, Tony, rather than all of it. So I'm going to roll with this. Had it just been this that I found, I might have been a little bit cynical, because it is the organization that has achieved this that's produced the video. And the academic in me says, what's the source? What's in it for them? And I might have been just a little bit wary. But because Oxford University have achieved something similar in a different kind of setup, and have also produced more energy from the process that was put in, I did start thinking, yes, this is worth sharing.
It sounds like it would need a lot of investment.